Hi, welcome back. This is Rakesh Naik. Today we are going to discuss about how to convert a regular expression to its corresponding NF. But before we start, a small information I'd like to share. In this channel, we produce every video in two different languages, Hindi as well as in English. And if you want to watch this video in Hindi, kindly follow the link given in the description. And if you have not yet subscribed, please subscribe and press the bell icon so that you will get regular updates from this channel. So, let us start. Before we start, these are the few things that we must understand. If a regular expression R is given, then we can find its corresponding finite automata. As we know, the finite automata is represented by 5 tuples, that is Q, sigma, delta, Q naught and F, which is supposed to accept the language generated by the regular expression. And by definition, we know that phi, epsilon and the input symbols are part of regular expression. They are in the regular expression. So let us see how these symbols are represented with the help of finite automata. When we are having the starting symbol alone or the final symbol alone, then we can represent it with the help of phi. Then epsilon is represented as a transition from one state to the other state. And when a symbol, let us say A is taken, then I can take this from one state to other state with input symbol A. So these three default regular expression can be represented in this way. Semantically, we can represent the acceptance of regular language L of R as this. From Q naught, there can be several transitions on this particular regular expression and it will go to the final state. Let us try to learn. Before trying to convert the regular expression, these are the few things that we must know. If R and S are the regular expression, then R plus S, R concatenation with S and clean closure of R are also the three operations that give me the regular expression. So whenever we are using the plus operation, we are taking case 1. If I am having two regular expressions R1 and R2 and I am using the union operation or the plus operation, we can construct an NFA which accepts L of R that can be represented as L of R1 plus R2. So it is represented in this way. This automata represent expression R1, this automata represent expression R2, and from the beginning state of both of it, I'll take a common starting state. From the common starting state, I can take epsilon transition to both the starting state of R1 and R2. And to make the final state, from the final state of both the NFAs, I can take epsilon transition to make another final state. This is basic idea that we are going to use. Let us take case 2. If R1 and R2 are two regular expression and I can construct R1 concatenation with R2 and the concatenated regular expression R will also be a regular expression. So it is represented in the form of L of R1 dot R2. If this is the NFA that I have constructed for expression R1 and this is the NFA constructed for R2, then I'll write one after another and give a transition. The initial state of R1 becomes the initial state of the whole NFA and there will be a transition from the final state to the initial state of R2. And the final state of R2 becomes the final state of whole R1 dot R2. These are the things that we are going to apply when we'll be doing a real problem. There is one more case. I can use clean closure. For clean closure also I can construct a NFA. If this particular NFA represents the expression R1, then I can represent clean closure of R1 as this. I'll take a transition from the final state of R1 to the starting state of R1 and I'll take another transition from A to B, which is an additional state that I am going to use. So with these three cases, says I'm going to represent any regular expression to NFA. Now let us see an example. Now we need to find a NFA for this particular regular expression. When I am saying the regular expression A plus B is whole star, then what kind of operation that I am going to perform here? I am having a union operation, I am having a chain closure operation, I am having two concatenation operations. So these are the operations that I am going to perform. And how to do these operations already we have seen. If I want to represent A plus B, it can be represented in this way. There is a transition from A to B. There is a transition from these two states and the transition is on A. I'll take another two state. The transition will be on B. And the plus operation I can do. I'll take another two state. One is for initial and one is for final. From E to A, I'll take a epsilon transition. From E to C, I'll take another epsilon transition. Similarly, from B to F, there is a epsilon transition, and from D to F, there is a epsilon transition. And F becomes the final state of A plus B. So this is how I am going to represent A plus B. Let us check how can I represent A plus B star. This is nothing but a clean closure. Now already I have seen this part. I am having AB, I am having CD. They are done parallelly, and E and F are my initial and final state for this. I'll take another two state, one for initial and one for final. From G to E there will be a epsilon transition. From F to H there will be another epsilon transition. And as I have already known, from F to E I'll take a epsilon transition, and from G to H I'll take another epsilon transition. This will give me the clean closure of A plus B. Now let us see how can I perform AB. So this is a concatenation operation basically we are going to use. So for A, I am taking two states with transition A. For transition B, I am taking another two states K and L. The concatenation will be from J to K, I will take a epsilon transition, and the final state will be the final state of the last transition. In this case, L is the final state of A, B here. Now, I got A, B's NFA and I got A plus B stars NFA. So, I am going to use one more concatenation here and I am going to get the whole NFA. So, this is the NFA that I got for AB. This is the NFA that I got for A plus B's star. So, what I'll do, from L to G, I need to make a connection. And it will be something like this. It will also be on epsilon. So this is the NFA that I got for AB, A plus B's star. For your better understanding, let us do one more problem. I am doing here 0 plus 1, 1 and 0 stars. For this regular expression, I am trying to find the NFA. Here I am using one more method where I will be introducing the states. So from A to B, this is my regular expression. Now you see there is a single operation here, that is concatenation. For concatenation, I'll get two different expressions. So I can get A 0 plus 1 1 and 0 star. I have introduced one more state C here. Now from A to C there is a plus operation, and from C to B there is a clean closure operation. For A to C, if I want to represent, it will be looking like this. And from C to B, it is 0 star. Now you can see here there is a concatenation on 1 and 1. I can represent this like this. In a 2 1s will be coming in a series. And at last I am having 0 star, and 0 star can be represented in this way. I to J there is a transition, from J to I epsilon, and from C to B there will be epsilon. So this is the required NFA for this particular regular expression. I hope you understood how to convert a regular expression to NFA. These are the most typical example where all the operations we have performed. I hope you understood these two examples. If you understood these two examples, any problem you can do. In our next video, we are going to talk about properties of regular languages. See you then. Take care. Bye.